Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics State Trial exam paper for year 2022. And this is Negeri Sembilan paper 1. Okay, let's get started with question number 1. So this is a question from the chapter Circular Measure, Form 5, chapter 1. So you're supposed to find perimeter of the whole diagram, given that this is major sector POQ with center O and the radius of the circle is 5 cm. It's very simple. If you know this is 90 degree, this angle over here, the major angle here will be 360 minus 90, which gives us 270. To find the perimeter, we need to find the length of this arc, and then you add the two radius here. The radius are 5 each. So what I need to do is to find the length of this arc. We know the formula for length of arc can be is given by the formula S equals to R theta. It can be calculated by taking the radius 5 multiplied with the angle theta. But take note that theta must be in radian. This is 270 degree. So we convert to radian by multiplying with pi over 180. Then we add with the length of your radius. And we have two of them. So we write 2 times 5 cm. Now 270 over 180, we can actually simplify to 3 over 2 pi. Okay, so we add with 10 and the result will be 15 over 2 pi plus 10. Take note, the question asks us to find the perimeter of the whole diagram in terms of pi. So you don't have to substitute pi with 3.142. Just leave it like this. If you want to write the unit is in cm, but it's not necessary to write the unit. If you want, you can go ahead and put cm here. Okay, question number 2. This is from the chapter linear law. We're supposed to express y in terms of x. Okay, when it comes to linear law, we always have to find two things from the graph, which is the gradient and the y-intercept. So for gradient, I'm going to take y2 minus y1. I'm going to call this x1. Maybe I call this as x1, y1, this is x2, y2, my y2 is 3, my y1 is -3, and then x2 is 1, x1 is 2. So this is 3 plus 3, 6, divide by -2, you get -6. Now to find your y-intercept, let's use y equals mx plus c, or you can use y minus y1, mx minus x1. So if you use y equals mx plus c, be sure you use a big Y. Your gradient is -6 big X plus C here, because this big Y represent the variable in the Y-axis here. The big X represent the variable in your X-axis here. So we pick a point. Yeah, in this case, I pick 0.13. Yeah, if you want to use 2 minus 3, you will get the same answer. So my big Y is 3. My big X is 1. Bring it over, -6, bring over becomes +6. My C is 9. Now C represent your y-intercept. So you know your equation is now negative big Y equals to -6 big X plus 9. So let's replace your big Y with y squared minus x squared. Replace your big X with just x. It is x here, as you can see from the graph. Now let's bring the negative x squared to the right. Your y squared is x squared minus 6x plus 9. Here I'm supposed to find small y in terms of x, so I need to factorize this. Now, on your right-hand side, you can see it's in the form of a squared plus 2ab plus b squared. We can actually factorize this into a plus b bracket square. So in this case, your a is x, your b is 3 with a negative, because the middle term here is -6. So you need to put a -3. And when you square root both sides, your y is now x minus 3. Okay, moving on to question number 3. This is from the chapter progression, Form 4, chapter 5. So the first thing is is given a y the length of w meter. Divides the y into separate divided y into several pieces. Each piece is to form a square. Yeah, the diagram shows the first 3 squares formed by INE. So you're supposed to state whether the perimeter of the square form an arithmetic progression or a geometric progression. Okay, we know perimeter means the sum of length of all sides. In this case, the first one you can see, the first square has length of side of B. Since I have 4 of them, we can say your T1, the first term that represent the perimeter, is 4p. The second term will be representing the perimeter of the second square. As you can see here, is p plus q. So here we have 4 times of p plus q. When you expand it, you get 4p plus 4q. Okay, how about the third one? The third one, you can see the length now increases to p plus 2q. Then you have 4 of them. So your perimeter is now 4 of p plus 2q. As I expand this, I get 4p plus 8q. Now, to show that this is arithmetic, remember arithmetic, the difference between two consecutive terms must be a constant. If it's geometric, the ratio of two consecutive terms must be a constant. One is a ratio, one is a difference. Now, it's quite clearly you can see that in this case, it is a difference, not the ratio. So I'm going to write over here that my T2 minus T1 in this case is 4p plus 4q minus 4p, which gives us 4q. And T3 minus T2 is 4p plus 8q minus 4p plus 4q. The 4p minus 4p disappear. The 8q minus 4q is 4q. Now, since T2 minus T1 gives us the same value as T3 minus T2, therefore we say this is a arithmetic progression. You can use short form of AP. AP stands for arithmetic progression. All right. With the common difference of 4q. So when you say justifying your answer, you just have to show that the difference is a constant. The difference over here, T2 minus T1, is the same as T3 minus T2. That's why you can work out what is the value of T1, T2, T3 first, and find the difference, and then show that the difference is a constant, which is 4q. All right. So the first part, I think, is quite okay and not difficult. Once you show there's AP, you don't have to show there's GP anymore. It cannot be a progression there's AP and GP at the same time. Yeah. Okay. Second one, B. If I only manage to form exactly 10 square, express W in terms of P and Q. Okay, the thing that you have to be careful about is this. This is in meter, whereas everything else is in cm, right? So we can say is S10 sum of the first 10 square, it gives us this value here. But this is meter. Remember, you got to change to cm. So let's just use the S10 formula. I already know my A. My A is 4p. This is my first term. I know my common difference. My common difference is 4q. So S10, remember formula for Sn is given as n over 2a plus n minus 1d. So my n is 10 divided by 2. My A is 4p. N minus 1 is 9. D is also 4q. Then you simplify further. Okay, it's up to you how you want to simplify this. Some students may divide first. This is 10 divided by 2, which is 5. And this will be 8p plus 36q. Now, your sum of the first 10 term is given as W in terms of W. In this case, W meter. But because the length are all in cm, we know 1 meter is 100 cm. W meter should be 100 W cm. Just add 0 in front because all these measurements are in cm. Now, next we can divide them. Up to you. You can multiply inside first, as in times in 40p plus 5 times 36 is 180q divide by 100. We can still simplify this and notice that we can divide top and bottom by 10, not only 10, 20. Yeah. So if I divide by 10, I get 40 divided by 10 is 4. You divide 20 is 2. 180 if I divide by 10 is 18. 18 divided by 2, I got 9q. 100 divided by 10, I get 10. 10 divided by 2, I get 5. You can use your calculator. You can just type in your calculator. Yeah, if you're not sure, 40 over 100 simplified to the lowest term is 205, right? And then 180 divided by 100 simplified to the lowest term, 9 over 5. There you go. You got your W in terms of P and Q. Okay, question number 4, this is from the chapter Differentiation from Phi chapter 2. So you're given equation, a curve fx equals this, and its gradient function is this. So we know if you differentiate fx, you will get the gradient function. This gradient function is f prime x. By differentiating them and comparing, differentiating fx, comparing f prime x, we can find the value of p and q. But to differentiate this, we have to use product rule. Remember product rule. If y equals to uv, dy dx will be copy your u, differentiate your v, differentiate your u, copy your v. Okay, you can see your u here is x squared. Okay, I will do one by one for you. U equals x squared. Your v is 2x plus 1 cubed. When you differentiate your u, you get 2x. If you differentiate a v, you bring the 3 down, copy 2x plus 1, reduce the power by 1, 2, differentiate inside 2. You can put them together to get 6 of 2x plus 1 squared. Now, when I differentiate dy dx, or we can write this as f prime x, I remember the formula is copy u, which is x squared, differentiate v, 6 with a 2x plus 1 square, differentiate u, 2x, copy v, 2x plus 1 power 3. Now, I know some of you may say, can I do u v prime plus v u prime? You can. It actually doesn't matter. But for me, I like to do it in this order because you see the brackets all arranged at the back is easier, right? The v is the term with the bracket, right? V is the one with the bracket. So if I copy u, differentiate v, differentiate u, copy v, you notice it's already arranged in this manner with the brackets at the back, easier to understand. Now, next we're going to take out common factor. Now, I know a lot of students find this is a bit difficult, a bit annoying. They're not sure how to factorize it, tend to mess up or miss out certain terms when they factorize. You can use the algorithm method. Algorithm method works like this. First, we take out, we arrange it in this manner. We take out the common factor. I'm going to start off with 2x plus 1 power 2. When you take out the bracket power 2, you're left with 6x squared for the first term. The second one, I'm left with 2x. I still have a bracket, 2x plus 1 with the power 1. Power 3 taken out power 2, left with power 1. I can still take out x. This will give us 6x. And the x here disappear, left with 2x. And left with 2 and a 2x plus 1. I still can take out a number. The number is 2. Sorry, you get 3x and a 2x plus 1. If you do it this way, yeah, chances are you can get the answer. You won't mess up, right? Or miss out any common factor. So we're going to take out 2x and a 2x plus 1 square here. Whatever that you're left behind here, we're going to put them together. 3x plus 2x plus 1. So whether you want to put a bracket here or not for 2x, it doesn't matter, not important. So this is 2x of 2x plus 1 square and a 5x plus 1. Now with that, we can find out our P and Q. We know that if I compare, let me write down the Px and the Qx plus 1. Okay, but before I do that, I realize that this Qx is written in front and the bracket square is written last. So you can actually switch them. Either I switch the 2x plus 1 square here, or you can put the 5x plus 1 in front. Doesn't matter. This is Qx plus 1. So it's very easy to see that your P value is now 2 and your Q value is now 5. So by comparison, you can say P is 2, Q is 5. Okay, question number 5. So this is a question that consists of different parts of the chapter. Part A, B, C, they're all 3 non-related questions. Okay, part A, they say, find the roots of this quadratic equation, giving an answer in terms of K. So normally in the event that you have an unknown in the equation, it's a bit hard for us to factorize using, the normal. It's a bit harder to find the roots by using factorization. So we tend to want to either complete the square or use quadratic formula. And I know a lot of students probably prefer to use quadratic formula, yeah, and don't quite like completing the square. So I'm going to write out the formula minus b plus minus square root b squared minus 4ac over 2a. Okay, my b is now negative k plus minus square root. This is negative k square for your a is 1, your c is 4, divide 2a, your a is 1. So this is k plus minus, this will be k square minus 16 over 2. All right, so I've got the value of the roots in terms of k. Yep, it's not difficult, all right? Just use a formula only. Okay, second part, B. You're given two graphs. The graph of fx equals ax squared plus bx plus c, and the graph of gx, which is bx minus 1 squared plus 1. The first one is given in what we call the general form. Second is given in a form, we call it the vertex form. And you're supposed to find the range of values of a in terms of b. Now, we know for sure, if your a is more than 0, it's a smiley face graph. If your a is less than 0, it's a frowny face graph, right? So we know number one, the first range you're going to consider is your a is more than 0. Number two, we also know that if you have the bigger the a value, right? For example, your a equals to 2, the graph will be sharper. Your a equals to 1, the graph will be wider, right? For the same value, the rest all being equal, the graph is either sharper or wider, or we say the width decreases, width increases. Yeah, the smaller the a, the bigger the width, the greater the width. So in this case, you can see that your fx here is wider compared to the graph of gx, right? Fx is, wait, gx is here. Maybe I highlight for you, a bit hard to see. Gx is the first graph here, is sharper. Fx is the green one here. Fx is wider. So if it's wider, a must be a value smaller than the coefficient of gx. In this case is p. So the problem is they give you in terms of unknown. So we have to write your a, yeah, in this manner. Your a is greater than 0, because if it's less than 0, then it's a frowny face. It can't be 0. If it's 0, it's not a quadratic, it's a linear graph, right? So it must be more than 0, but at the same time, less than p. So your answer, a, is between 0 and p. Okay, that is Roman 1. Roman 2. Write a new quadratic function of gx if the graph gx moves 5 units to the left. Okay, if you move gx 5 units to the left, what happens is that we have what we call a horizontal translation. Your x value, the axis of symmetry is now shifted, right, to the left, and it becomes negative. So equation-wise, what we do is we just add x minus 3 here, add a 5. Yeah, remember, x has an opposite, what they call the effect compared to y. So for example, y, right, if I have a graph, for example, x squared plus 1, if I plus 5, I'm shifting up. If I minus 5, I'm shifting down. But whatever inside the bracket is different for x, because when you minus 5, I'm shifting to the right. When you plus 5, I'm actually shifting to the left. Yeah. So in this case, we have to add 5 to here. And what happened to your equation? Okay, we had to write b x plus 2 square plus 1. Everything else remains the same. Only the bracket here changed to x plus 2. All right. Moving on to C. Given that straight line y equals mx minus 3 intersect the curve y equals to x squared minus 3x plus 5m. Okay, maybe I do it over here. They're unrelated to the previous part. Okay, at 2 different points, find the range of values of m. Okay, now when 2 lines intersect each other, number 1, we can call this equation 1, call this equation 2. We can sub equation 1 inside equation 2, solve them simultaneously. The first one is mx minus 3. The second one is x squared minus 3x plus m. Next, we bring everything to the right-hand side. I'm going to write Okay, I'm going to write minus mx plus minus mx minus 3x plus m plus 3 equals 0. Now we need to factorize these two first. Take out negative m plus 3x plus m plus 3 equals 0. Now we know when a straight line and a curve, they intersect at 2 points. The number of real root that you have is the 2. We will have 2 real root, or we say real and distinct root. So we have to use b squared minus 4ac more than 0. Now my b is negative m plus 3. I'm going to square it, okay? Now I'm not going to expand the negative. I'll just leave the negative outside. Your a is 1, your c is m plus 3. This is more than 0. So the moment you square the negative 1 square, imagine there's a negative 1 here. You got to square it, and the m plus 3, you're going to square it. The negative 1 square is going to give us 1, right? Now, I'm not going to expand the bracket because I can see that they actually have the same common factor, which is m plus 3. I have m plus 3 here, right? Let me highlight using red pen. This is m plus 3 here, m plus 3 here. So instead of expanding and factorizing back, I'm just going to take out my common factor. When you take out m plus 3 from the first one, we are left with an m plus 3. If I take out m plus 3 from the second one, I'm left with negative 4. Now take note of whether you put a bracket here or you don't put, it doesn't really matter, right? So you're left with m plus 3 and m minus 1 more than 0. So since we have a quadratic inequality here, we can first find out the roots. Remember, to solve quadratic inequality, we have to sketch a graph. Now, to find out the roots, right, this is m. We just let this be 0. Okay, mentally let it be 0. Find out your m. Your m is negative 3. Yeah, m plus 3 equals 0. M minus 1 equals 0. M is negative 3 and 1. These two represent the intersection with the m-axis, not x-axis, it's m-axis. But since I want it to be more than 0, I hope we all know that this more than 0 or less than 0 here, this inequality symbol here, determines where I should shade the region. So in this case, more than 0, the region is up here, is above, right? And what are we finding? We're finding the range of values of m. What are the m value when the whole thing, the whole graph here, this is your y if you like, is more than 0. When it's more than 0, it is above the m-axis. So this is y equals 0. This is y more than 0. The region below is y less than 0. I want it to be more than 0. So it is here or here, right? So my range of values of m should be either less than negative 3 or more than 1. So what we're saying is that if your m here is less than negative 3, like negative 4, negative 5, or more than 1, like 2, 3, 4, and I sub inside these two equations here, when I solve them simultaneously, they are going to intersect each other at 2 different points. Yep. Okay, question number 6, we have a diagram that shows a cross-section of 3 cylindrical container, each a radius of 3 cm, is held together by a stretched elastic band. So we are supposed to find the area shaded region. Okay, if you have all these 3 circles touches each other at one point, so we can draw a line that connect the center of the circle together, right? Connect the center of the circle together, as you can see. And we know since this is the radius is 3, this is 3, this is 3, this is 3, all of them are 3 here. So what we have here is an equilateral triangle with the radius, with the length of sides of 6. And this angle automatically must be 60. So if you want to find the area shaded region, what we can do is we take this triangle here, we subtract 3 times of the length of area of one sector. Now, each sector has radius of 3 cm and angle subtended at the center of 60. Okay, we know from the chapter solution triangle that area of triangle can be calculated by using, let me write over here, half AB sine C. So your A and B, in this case, they are 6 and 6. You can write 6 square. sine 60 degree. As for area sector, you can calculate by using half r square theta, right? And theta must be angle in radian. So I take 3 times of half because I need minus 3 of this sector. Your radius is 3 square. Your theta is 60. Please convert to radian by multiplying with pi over 180. Okay, we can simplify this. A half times 6 is 3. 3 times 6, 18. Sine 60 is 3 over 2. I can show you using calculator. Sine 60 is 3 over 2. And this is going to give us 3 squares 9. 9 times 9 times 3 is 27. 27 over 2. And 60 times pi over 180 is actually pi over 3. And we can simplify further to 9 sub 3 minus 27 divided by 3 is 9. 9 over 2 pi. You don't have to live in pi form. And here the question say use 3 pi as 3.142. So I'm going to type in my calculator 9 sub 3 minus 9 over 2 pi is 3.142. Yep. And my answer is 1.449. 1.449. Okay. So second part. I want to find the length, the stretch length of the band. So we're going to find or calculate the length of this side here. So yeah, first I'm going to take this length, the red line. Now we know that we can join this together at the center, and you can see this is a right angle, right? Because the line touches the circle at one point, it's a tangent, 90 degree, 90 degree. Hence, all these sides, they have the same length as the length of side of your triangle, which is 6, right? They're all 6. 3 plus 3 is 6. Okay, can you see that? Now, what I need to do is to add the length of this arc. 1, 2, and 3. Okay, since this is already 60, okay, maybe I think I don't have to zoom in. This is 60. That is 90 and 90. So this arc here, we can think 360 minus 60 minus 90 minus 90, right? So 360 minus 180 is 180. 180 minus 60 is 120. So each side has angle, yeah, each length of arc here has angle 120. You can write in radian straight away, which is 2 pi over 3. So you want to find the length of this tree, the 3 red one and the 3 green one add together. So the length of the band that is required, maybe I start off with the length of arc, the green one, which is, we can use S equals to R theta. Since I have 3 of them, your radius is 3, your theta is 120, but you got to convert to radian. Remember, S equals R theta. R is a radius, theta is angle in radian. Then you add 3 of 6. The 6 are the length of this side here, right? They're all the same. So we can simplify this. You can write 9 of pi, 2 pi over 3. This is 2 pi over 3. You can actually do one shot. Don't have to do so long. All right. This is 18. Can simplify further. Cancel, cancel. You got 6 pi plus 18. Now, again, you need to use 3.142. So even if you don't write like this, you type in your calculator straight away, is okay as well. Yeah, I just want to show you 3.142. I will show you in terms of pi first. Then you plus 18. My answer is this, 36.85. Yeah, 36.85 for significant figure is enough. Okay. Question number 7 is from the chapter vectors. So from chapter 8. Now, first, we are supposed to find unit vector in the direction PQ, given this diagram here. But we can count the number of boxes here. You can see this is 5 unit to the left. So we write -5. This is -5i, right? And we go up by 2 unit. You can write positive 2j. So before you find unit vector, let's find out what is vector PQ. vector PQ is minus 5i plus 2j. Okay, now to find unit vector, remember unit vector means one unit of the vector. If the vector has the magnitude of 1 unit, what is the vector, right? But first we have to find what is the magnitude of this PQ, right? PQ is U. The magnitude PQ is negative 5 square plus 20 plus 2 square root. So it's a square root of 29, right? Square root 29 about 5 point something. So we have 5 point something unit here, but I only want 1 unit going in this direction. So to find 1 unit going in this direction, I just have to take this vector PQ divide by the total magnitude of 29, square root 29. So we write U with a cap. This is a unit, or should I say the notation for unit vector. We take vector PQ minus 5i plus 2j divide square root 29. There you go. That's your unit vector in the direction of PQ. Okay, next, I want to find the maximum now unit vector that would fit inside line of PQ. Very simple. We already know this length. We know this length has a magnitude of square root 29. And square root 29 is approximately 5.385. Yeah, square root 29 is 5.389. So how many unit vector can I have? The most. Well, I can't exceed this number, right? So the maximum number of unit vector I can have is just 5, right? So for example, I can draw here like this. This is 1, this is 2, this is 3, this is 4, this is 5, and a little bit more because it's 5.3 something. I can do 6 because if I go 6, it'll be exceeding the length of PQ. All right, that is the first part. Second part, vector A is given, vector B is given, and you're given JH is 2A plus B. Okay, so let's find out what is JH. 2A, my A is now 3I minus 4J. This is unrelated to part A. And 2B plus B. B is minus 2I plus J. As we multiply inside, you get 6I minus 8J minus 2I plus J. You will get 4I minus 7J. Okay, now I know magnitude of JH is 2 times of magnitude of KL, right? That means KL is shorter, right? By half. It is shorter. It's half the length of JH. At the same time, KL is moving in the opposite direction of JH. Meaning, if it's moving in the opposite direction, we need to put a negative. At the same time, it's only half the length of JH. So we put negative half JH. And we know JH now, right? Okay, let's move this up a little bit. We know JH is 4I minus 2J. So when you multiply inside, KL has a vector of negative half times 4 is negative 2I, minus half times minus 7, positive 7 over 2J. There you go. That is vector KL. Okay, question number 8. This is from Form 4, Chapter 7, Coordinate Geometry. So the diagram shows position of 3 players in the same team in a video game. Valerie. So the initial position of the players A, B, and C, they are given the coordinate as shown in the diagram. So the initial position from a triangle, find the value of Q if the area triangle is 36. Okay, area triangle ABC. You can join this together. Actually, you don't need draws, never mind. Okay, but one thing I want you to know, if you calculate the area by using the formula half x1, y1, x2, y2, x3, y3, x1, y1. Remember, if you choose the point in the clockwise direction, whatever I'm getting here inside should be negative, right? Since area cannot be negative, we just make it positive. We just, in a way, modulus it, right? If you use anti-clockwise direction, then it's going to be positive. So in this case, since you're finding a value of unknown Q, right? Rather than doing plus minus, I will straight away use anti-clockwise. Then I only take the positive value. So I don't have to waste time calculating 2 sets of answer, right? So yeah, remember that. If you're not sure, you just modulus both. I mean, open up modulus, put both answer, then work out your Q. Your Q should be above here. More than 0 is positive value. Okay, but I want to only find one answer. I don't want to do both. So I'm going to choose the direction in anti-clockwise. I start with point A, which is 1, 6. Point C, 3 minus 4. Point B, 8Q. Repeat the first point. Your answer is 36. Okay, so let's multiply downwards. I remember downwards first. Then you minus multiply upwards. Okay, so keep my half here. 1 times minus 4 is minus 4. 3 times Q is 3Q. 8 times 6 is 48. Okay, you minus, you can put it together if you want, as in a bracket like this. This is 18 minus 4 times 8 minus 32. Q times 1 is Q. This gives us 36. Okay, I just put a bracket like this. I don't have to treat like a modulus because, like I say, I've already chosen anti-clockwise. It's going to be positive, right? So I keep the half first. This will be 3Q plus 44 minus Q. 18 minus 32. That will be 14. So it's negative, negative, positive 14. The result will be 36. Then half of 2Q plus 58 will be 36. You can choose to multiply the half over 36 times half, but I can see that this is going to be divisible by 2. So I half it straight away. Half times 2Q is Q. Half of 58 is 29 equals 36. 36 minus 29, Q is just 7. Okay, first part, not difficult. Okay, second part. One hidden weapon is located at a perpendicular bisector of line joining BC. Find equation that describe the possible location of the weapon. Okay, there are two ways to look at it. You can actually go and form equation of perpendicular bisector, or we can use equation of locus. So I think locus is a little bit shorter, so I'm going to use short locus here. We know in order for it to be on the perpendicular bisector of BC, we can use locus of point P. We can call PXY. It's a moving point such that it passes through the midpoint of BC and perpendicular to it. We call it a perpendicular bisector. So we can say BC equals to BC. BC equals to PB. Okay. Now let's use the formula for distance. We use x minus x1. Your C is 3. We square it. Okay. The y is minus 4. Minus minus is plus 4. Okay, let me fix this a bit ugly. Plus 4. We square it. The result is PB. PB will be square root x minus 8 y minus q. I know q earlier. Q is 8. Okay, I'm going to take this and I'm going to expand it. Let's square left and right hand side. Yeah, when you square both sides, the square root disappear. I'm going to expand the bracket here. X squared minus 6x plus 9. I hope you can expand very quickly by now. This is y squared. 2ab is 8y. 4 squared 16. This is x squared, 16x, and 64. This is y squared, 14y, and 49. Now here we can cancel your x squared and x squared. Yeah. Now life is easier if you just cancel everything, right? Cancel all the common term, y squared, y squared. So let me do a bit slower. I'm going to write the minus 6x plus 8y plus 9 plus 16, 25. Okay. And on my right hand side, I have minus 16x minus 14y, 64 plus 49. Okay. 64 plus 49, 113. Okay. Then bring this negative 16 to the right. 16 bring over, negative 16 bring over, become positive 16. 16 minus 6 is 10. 8y plus 14 is 22y. 25 minus 13, it will be 188, right? Equals 0. We can divide by 2. I got 5x plus 11y minus 44 equals 0. We can live in any form. Okay, I just want to show you the alternative method to this. You can actually use equation of perpendicular bisector as well. Okay, but to do that, let me do it over here. Number one, let's find out the midpoint. Your midpoint is 3 plus 8 over 2. Number two, we take minus 4 plus q. Q is 7 over 2. This is 11 over 2 and 3 over 2. I also need to find the gradient of line BC. Let's use y2 minus y1. Remember, your q is now 7. 7 minus 4 over 8 minus 3. This is 11 over 5. Okay, since I'm finding perpendicular bisector, remember when two lines are perpendicular to each other, m1 times m2 equals -1. My m2 is -5 over 11. And to form equation of straight line, I use y minus y1. My y1 I have to use 3 over 2, gradient of perpendicular line, -5 over 11, x minus x1, 11 over 2. Okay, I know the number here a bit ugly, so we can, okay, maybe I times inside first. I do 1 by 1, 5, 11 here, right? I changed my mind. I think I times in is easier. Yeah, I times over is easier. Times over, this is 11 y minus 33 over 2 minus 5, I times in, plus 55 over 2. Okay, bring this over, right? Or you can bring the other one over as well. Okay, I think I bring everything over. 5x bring over becomes positive 5x, 11y. So minus 33 minus 55 is minus 88. You divide by 2, minus 44. Now notice you're getting exactly the same answer as using the first method. Now, I actually prefer first method because I look at it, it's shorter. But if you are more comfortable with forming equation straight line, yeah, first you have to find, we call it a perpendicular bisector. Find the gradient, find the midpoint, find the perpendicular gradient, yep, and then only form the equation straight line. Yeah, both methods are also okay. Okay, question number 9 is from the chapter integration. So the first part, you're given these three information here. You're given this integration of 1 to 3 fx dx. Fx dx is p. Second one, integration of 3 to 5 fx dx is q. And the third one, integration of 1 to 3 gx dx is r. So for the first part, you're given this integration. You're supposed to find integration of 1 to 5 fx dx. Okay, understand this. 1 to 5, there is what we call the characteristic of definite integral. So 1 to 5, this is for the explanation. 1 to 5 fx dx, we are referring to this area. We can actually split it to 1 to 3, 3 to 5. Yeah, so we can write this as 1 to 3 fx dx plus 3 to 5 fx dx. Now, why do I do that? Because I know my 1 to 3. I know my 3 to 5. However, take note, 1 to 3 is not a problem. It's quite simple. You can just sub inside. But your 3 to 5, you have a 3 inside. So in order to leave your answer in terms of P and Q, I must make sure I have a 3 next to my fx. So what I'm going to do is I'm going to put a 3fx here. Yep, there's a 3 to 5. And I balance it out by putting a 1 over 3. Now, alternately, some of you may say, can I start from here, 3 to 5 fx dx? And then from here, right, I straight away divide it by 3. Take the 3 in front, just bring it over underneath the q. You can do that, right? But here, since I want to write in the whole line like this, so I'm going to put the 1 over 3 in front, multiply with integration 3 to 5, 3 fx dx. So this result is going to give us a p. Yeah, the first answer is p. Second one, there's a 1 over 3 in front, and this value is q. So answer is p plus 1 over 3 q. Okay, this is only part A. Part B, I'm going to do it over here. Now, you're supposed to find the whole expression here in terms of r. Okay, remember, r is a constant, like a number. It's not a variable, it's a number, fixed number. So there is a constant in front here, 2r squared. I'm going to take out 2r squared. I'm going to integrate 1 to 3. There is an x here, x dx. At the same time, I'm going to split it. Yeah, split the gx. We are going to write gx dx 1 to 3. Okay, this part here we have to integrate. remember r is a constant, leave your r out. Integrate x, you get x squared over 2 from 1 to 3. Integration of 1 to 3 gx dx is going to give us r. I'm going to write r here. So this is 2r squared. In fact, the 2 and 2 you can cancel. If you cancel them out, you're left with r squared, right? I'm canceling these two out, okay? And I have to put the 3 inside, 3 square, okay? Let me write using black pen, 3 square minus 1 square minus r. 3 square is 9, 9 minus 1 is 8. So you have 8 r square minus r. There you go. That is your answer for B. Yeah, your answer will be in terms of r. Okay, next question, question 10 is from the chapter progression. Try and use colored triangle cards of different sizes to investigate the patterns of spin skier triangle. So diagram shows the patterns. Yeah. So they say the height of the second stage triangle is half the height of the first one. And you can see it. Basically, this is 20 and 20. So since you have 4 triangle here, you take 20 divided by 2 further. This is 10 each. Yeah, your triangle getting smaller and the number of triangle actually increases. The first one, you have 1 triangle. Second one, 3 triangle. You notice the third one, you have 9 triangle. Okay, so the first part, find the height of the triangle used in the 7th stage. Since we can see the first stage, right, you have height of 40. Second stage is half of it. So immediately we can tell it is a geometric progression with common ratio of half. To find the height of the triangle in the 7th stage, we use T7. The formula for Tn, remember, is given as A, R, N minus 1. Your A is 40, your R is half, your N is 7, 7 minus 1 is 6. So in this case, let's take 40 bracket 1 over 2 power 6. This answer is 5 over 8. Okay, 5 over 8. All right, second part. They say find the number of triangle in used in the last stage. If the height of the triangle at this stage is 5 over 64. So now we know our Tn, 5 over 64. You're finding the number of triangle used. That means you're finding, first you find n, then you need to multiply, right? Okay, so first of all, my formula is A, R, N minus 1. Okay, let me write down your N minus 1. This is 5 over 64. Okay, let's divide it. 5 over 64, you can divide by 40. 5 over 64, you divide by 40, you can get 1 over 512. So 1 over 2 power n minus 1, 1 over 512. Now 512 is 1 over 2 power a number. Now you're not sure about this. If you have this calculator has a shortcut button. You press 512, press equals, press shift, factorize. You change first to 2 power 9. Now, if you don't have this calculator, you have to do trial and error. For example, 2 power 8. Do you get 512? No. 2 power 9. Yes, 2 power 9 is 512. So here we write 2 power 9. By comparison, by comparing the power, n minus 1 is 9, n is 10. Okay, but I hope you notice that this number of triangle, if I take the next stage, this one you times 3, you times 3, you keep multiplying by 3. But by itself, the number of triangle is another progression, right? Where your A, the number of triangle, your A is 1, your R is 3. So we know at stage number 10, right? You keep, when your height of your triangle is 5 over 64, your number of triangle will be 1, 3, power 10 minus 1, 9. Yeah? Your A, R, N minus 1. Your N is 10, 10 minus 1 is 9. So you have 3 power 9 triangle, which is 19683. Yeah, 19683. Yeah, that's the number of triangle that you have. Okay, that is only part A. Moving on to part B. Okay, you're given that A is the first term and R is common ratio of a geometric progression. If the magnitude of R is more than 1, show that the sum of this progression is this. Okay, so this is a proving formula, proving a formula for sum of the first n term of a geometric progression. So we know Sn can be calculated by using A, first term, add the second term, AR, add the third term, AR square, and so on. Now you don't have to write all, just put dot 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 until the last term, AR n minus 1. Yeah, remember Tn is AR n minus 1. Now I need to eliminate all the terms in between, right? Because you see the final answer, you don't have everything. We just have the A and Rn and R, right? So we call it equation 1. Take equation 1 multiply by R. So when you multiply by R, what happens is this A becomes, okay, maybe I put this a bit closer. Equation 1 multiply by R, this is RSN. A times R, you get AR. AR times R, you get AR square. AR square times R, you get AR cube, and so on until the last term is ARN. Yeah, just so you know, ARN minus 1. When you multiply R power 1, it is actually n minus 1 plus 1, which is just AR to the power n. So this is your equation number 2. Okay, I want to get rid of all the terms in between. So I'm going to take equation 2 minus equation 1. So when you minus that, you can write RSN minus SN. Now what happened is this AR you can minus with this AR. This AR square will minus with AR square here. Your AR cube will minus with the next term all the way. Now the term before this, should I write here? The term before this is AR n minus 1. You don't have to write this up, but if so, I'll have to cancel all the way. Now the only one that is left is my A here and my AR power n. So we write AR power n, since I'm taking equation 2 minus equation 1. You minus the only term that's left here, which is A. And at this stage, we can factorize your factorize your Sn. You're left with R minus 1. Factorize your A. You're left with Rn minus 1. As we are finding Sn, just bring the R power R minus 1 down. There you go. You got this answer already. Okay, question number 11. This is from the chapter Permutation Combination. But the first part is basically using the formula for NPR. Okay, just so you know, NPR, the formula is given as n factorial n minus r factorial. So if you want to find part A, if you want to solve this equation, that means you're finding for n, we need to apply this formula to this. This is 2n, right? Your n is now 2n factorial divide 2n minus n factorial. Okay, for my denominator, so maybe I just copy this down first. This is 2n minus 2 factorial, right? Then you equate it with 10 over n factorial, 10n over n factorial. Okay, it looks a bit long and annoying. Now, we know we can cancel, maybe I bring this over first. This 2n factorial, 2n minus n left with n factorial. Maybe I bring this over first, easier, don't have to write so many things. All right, we can cross out n factorial in n factorial. Now for 2n factorial, remember what is 5 factorial? 5 factorial is 5 times 4 times 3 times 2 times 1. Or sometimes you can write 5 times 4 times 3 factorial, right? So if you have 2n factorial, we can actually break it down into 2n minus 1, 2n minus 2 factorial, and so on. Now, why do I do that? Because I can see there's a 2n minus 2 factorial on my right-hand side. So I'm going to break it out to 2n minus 1, 2n minus 2 factorial. I'm left with 10n and 2n minus 2 factorial. Now, these two, again, we can cancel. I'm going to cross them out, cancel out. At the same time, I can expand this bracket. I got 4n squared minus 2n. Your outcome must equals 10n. Bring the 10n to the left. 4n squared minus 12n is now 0. Take out a common factor, 4n, n minus 3. N cannot be 0. N has to be 3. All right, so that is part A. Okay, part B. Let me rub it here, rub it off. Part B, maybe I can do it below here. Yeah. Okay. Part B. One Shashita arranges 8 beads to form a bracelet. Okay. How many different bracelets can she form if 3 beads are of the same color? Okay. So here we have to use. Okay. Let's talk about arrangement in a row first. When you arrange that item in a row, so how many ways we can arrange them? 3, 4, 5, 6, 7, 8. So if you arrange in a row, the number of ways is 8 factorial. But let's say if identical arrangement, right? Remember, if identical arrangement, identical item, then you got to divide by 3 factorial. For example, this bit is, let's say the bit is blue, blue, and blue. If you put B1, B2, B3, they're different arrangement compared to B2, B1, B3 here or any other arrangement. But the moment you take out the number, they all appear to be the same bits, yeah? The same blue bit, blue bit, blue bit, let's say, for example. So we always have to divide 3 factorial to cancel out the number of arrangement. Okay, so that's number 1. We arrange in a row, we divide by identical item, we divide 3 factorial, so we know that's arrangement in a row. But when you arrange them in a circular manner, 1, 2, 3, 4, 5, 6, 7, 8. So the thing you need to understand about circular arrangement is that they will have the same position in terms of what is on the left and right hand side. For example, maybe I put, for example, I put a yellow here. All right. Yellow will have green and let's say blue. Green on its left, blue on its right. And when I rotate this, okay, 1, 2, 3, 4, 5, 6, 7, 8. Now let's say I put yellow now on this position here. And then you still have green on the left and blue on its right. So there are basically 8 different positions I can put my yellow bits, right? I can put the yellow bit, let me right here. I can put the yellow bit here, 1, 2, 3, 4, 5, 6, 7, 8. And basically, I'm just rotating like this, just like this bit. I can just rotate it like this. I'll have 8 similar arrangement. Or should I say 8 identical arrangement? You have the same number on the left and on the right. So if I say, oh, the number of arrangement is just 8 factorial, then it is wrong because you will have the same position, a different position, same arrangement. So that's why you always have to divide by 8. Okay, we divide by 8 for in the event that they don't have identical. But this one, we already have 3 identical. I still have to divide by 8 here, right? Now, some students will say 8 factorial divided by 8. We can just write 7 factorial. Yes, you can do that, right? You minus 1, right? 7 factorial. Okay, the next thing you need to understand about bits and or bracelet, yeah, all this, right? Because they are items that you can flip. If you're talking about human, putting human in a round table arrangement, right? So let's say one guy is seated here, another guy is seated here. Well, you have different arrangement. Let's say Ahmad is seated, has Ben on his right, Chandan on the left. So we cannot flip them upside down, right? Yeah, we can't do that, right? Okay, so but bits you can. For example, if I take this and I flip it this way, this is called the mirror image. So yellow still in the middle, but green is now on this side, blue is on this side. But it's actually the same arrangement. Yeah. You say, okay, sorry, I put the green color here, supposed to be blue color here, right? It's a mirror image. So you take a bit, it can be keychain, can be bracelet, can be necklace. You flip it this way. Yeah, sorry, mine is the same color, black. But if a different color, you flip over, it's actually the same thing. The same arrangement of item, right? So that's why you always have to times half. Okay, let me rub this off. You always have to multiply by half. Only for necklace, bracelet, key, and so on. Okay, so you times half. My final answer, you can take the 8 factorial divide 8. You can write 7 factorial if you want, 7 factorial. You divide by 3 factorial, all right? And then you multiply by half, yeah, times half, or you can write divide by 2. And my answer is 420. Okay. All right, so that is part B. Okay, part C, we have Harris that owns 5 shirts, 7 pairs of pants, and 4 pairs of shoes. So how many ways can he choose the 2 items to pack for a vacation? So very simple. 5 shirts, he choose any 2, right? 7 pairs of pants, you choose 2, and 4 pairs of shoes, you choose 2 as well. Okay, because this arrangement are not important. Now you can take shirt A, shirt B, shirt B, shirt A is still the same combination. What we want is a combination. So I'm going to type in my calculator here. This will be 5 choose 2 times 7 choose 2 times, oops, my 7 is missing. 7 choose 2 and 4 choose 2. Yep, my answer would be 1260. 1260. Okay. Okay, question number 12. So a diagram shows, this is from the chapter normal distribution. Yeah. A diagram shows 2 normal curve A and B with mu equals to 500. Okay. So mu represent the middle value here. This is 500. Okay. So if the variance of data x and y, they are 1002 and 3006 respectively, determine the appropriate curve representing x and y. Okay, one thing I hope you know, variance of standard deviation determines how far data being spread out. If your variance of standard deviation is higher, the tail, you have to pull it lower. The graph will be lower, right? They are more spread out from each other. If your standard deviation or variance is lower, the graph, the values are all closer to each other, all right? For the same mu or mean, right? Data is closer to each other, therefore the graph is a bit taller, right? So in this case, definitely the normal curve A will have a higher, should I say a lower variance or standard deviation, all right? Normal curve B will have a higher variance of smaller or standard deviation, okay, higher, because it's more spread out from each other. So how do you write answer for part A? Okay, they say which one is your, okay, I'm supposed to write here. I can write inside here, data x and data y. Okay, so answer for A, determine appropriate curve. So for data x is a normal curve. X has variance of 1002, so it's smaller, right, compared to y. So we say normal curve A. Yeah, A is closer, so the variance is smaller. Data y must take normal curve B. Why? The variance is bigger. The graph is more spread out. The variance is 3600 is bigger. The graph is more spread out from each other. So answer is normal curve B. All right. The second part. Right, let me do part B. Part here, part A, I've rewritten the answer here. Part B. Now, a jar contains 4 green marble, 4 green, 7 red, 9 white. 3 marbles are taken out random, one after another without replacement. State whether the probability distribution is binomial or not. Now remember binomial, the way I'll teach my student how to remember is to think FITC. What is FITC? F for fixed number of trials. Okay. What is I? I for independent. What is T? T for 2 possible outcome. All right. And what is C? C for constant probability. All right. Now, in this case, independent and constant probability are quite similar, quite related to each other, because the keyword in this case is without replacement. If you draw without replacement, what happens is the probability will not be constant, right? And whatever I'm drawing in the first attempt will affect the outcome of the second attempt. Whatever I'm drawing in second attempt will affect the outcome of the third attempt, right? Because you draw, you don't put back. If you draw and you put back, every time I draw, the chances of getting, say, the red, the green, or the white, they're always the same, right? So, okay, how do you answer the question? Okay, we say, no, it's not independent. Determine state whether state whether it's binomial or not. So it's not a binomial, because binomial, it has to be independent. It has to have fixed number of trial. Can we have fixed number of trial? Yes, because you're drawing 3, right? We know that the biggest problem is it's not independent. So we say it's not independent, or you can say the probability is not constant. Just explain briefly why. Why is it not independent, or the probability is constant? We say that the probability, for example, of getting, what marble is this? Maybe I say green marble. Green marble in the second attempt, right, depends on the color of marble taken in the first attempt. For example, to explain this further, so let's say I get green in the first attempt, then I get green in the second attempt. First time green is 4 over, how many marbles you have here? 20. Second time green will be 3 over 19. Now, if you get a different color, let's say you get red and green. First time you get red, 7 over 20. Second time get green, 4 over 19. You see, the chances of getting green in the second attempt depends on what you're getting in the first attempt, right? So if you get red, or even any other color, or even white, the chances of you getting it in the first, the green marble is different, is not the same. So all you can say, the probability is not constant. The probability of getting green marble in each attempt is not constant. You can also mention that. Okay, I don't think you write this probability out. You just mention that it's not independent, and you can say the probability of getting the second attempt, green marble second attempt, depends on what you get in the first attempt. Okay. Okay, question number 13. So here we have a graph that represent the absolute value function fx for the domain 0 to 4. State the value of k. Okay, you can see the smallest value, the lowest point in your graph is at -1. Remember, this k is actually -1, right? You can actually write it straight away, right? Let me write over here, k equals -1. Okay, now in a way, the modulus graph behave a similar way to a quadratic function. So if today I draw 2x minus 3 square minus 1, this is a quadratic function graph with your axis of symmetry at 3 over 2 and the minimum value at -1. So you can draw like this. This is your y-axis and x-axis. So it looks something like this. That is -1. Okay, but for a modulus graph, it's a V-shape. So if I just change it to fx equals modulus 2x minus 3 square minus 1, it is a V-shape, but your axis of symmetry is also at 3 over 2, and your y-intercept, your vertex is also at -1, the minimum value. Okay, so in this case, we can just write straight away k equals -1. It's only one mark, state the value only. Okay, how about you finding the x-intercept? Okay, we know at x-axis, your y is 0. Okay, let me write here, x-axis, your y is 0. Now that I know k is -1, so modulus of 2x minus 3 minus 1, we'll let it be 0. Bring this over to the right, you get 1. When you open up modulus, there's always a plus minus, so a -1 and a +1. Let's bring this over. My 2x minus 3, bring the -3 over. This will be just 2. Yeah, 3 minus 1 is 2. 2 divided 2, x is 1. Second one, 2x is now 4. X is now 2. So this x-intercept, we just confirm, is 1 and 2. There you go. That's your answer for B. Okay, next we want to find the domain for fx less equals to 1. Okay, we can draw a horizontal line here. This is a horizontal line of y equals to 1. So 1 is here. So for me, maybe it's easier to let fx be 1. Then we find our intercept. So we take 2x minus 3 minus 1 equals to 1. Quite similar to part B. Bring the 1 over first. And again, when you open up a modulus here, we have a negative and a positive. You bring the 3 over, you get 1. X is 1 over 2. You bring the 3 over, you get 5. X is 5 over 2. So this is now your 1 over 2. This is now your 5 over 2. Okay, your fx, you want fx to be less equals to 1. Less equals 1 means it must fall below the line y equals 1. When it falls below line y equals 1, the range of values here, it must be between half and 5 over 2, right? So we say your x value is between half and 5 over 2. If the question 1 fx greater equals to 1, then it will be anything more than that. In this case, it will be more than this, for less than 1 over 2, or more than 5 over 2. Yeah, but we don't want that. We want the range that is below y equals to 1. So it's anything between half and 5 over 2. Okay, next, find the range of the values of x that is mapped onto itself. So when the graph is mapped onto itself, we say your fx is equals to x. Again, we use the formula 2x minus 3 minus 1 equals to x. Bring the 1 to the right, negative 1, bring over, you get x plus 1. Okay, one thing about modulus, I like to open up the modulus one by one. So I hope you understand that when, okay, but this is a different graph altogether. Like for example, 2x minus 3, you have a positive side, which is this, and a negative side, which is negative of 2x minus 3. So again, now when you open a modulus, there's a plus minus. I just put a negative here. You can bring over the negative side of this versus the positive side of this. It is now equals to x plus 1. So there are two x value that we have to consider. So let's multiply negative inside. Minus 2x plus 3 is now x plus 1. Bring over 3x is, I bring to the right hand side. 2x plus 1x is 3x. I bring 1 to the left. 3 minus 1, you get 2. X is 2 over 3. For the second one, I bring this over. Your x is just 4. Okay, your x is 2 over 3 and 4. Now look at your graph here. 2 over 3 and 4. They're all well within this domain. Okay, maybe I show you here. If you can actually draw a second graph of y equals x. The second graph y equals x should be a graph like this, right? Okay, a bit ugly. One more time. A graph like this. You notice there are 2 points of intersection. The first one is here at x equals 2 over 3. The second one is here at x equals to 4. You got 2 answers. Okay, so in this case, we can accept both answers because it must fall within the domain and they are both well within the domain. Your maximum is 4. So there you go. X is 203 and 4. Okay, question number 14. You're given that cos x equals to 1 over m such that x is an angle between 0 to 90, pi over 2. Express tangent to x in terms of m. Okay, this one I would draw a triangle like this because it's a right angle triangle. The angle x is anything between 0 to pi over 2. Pi over 2 is 90. Now we know cos is a ratio of adjacent over hypotenuse. So for this angle, your adjacent is 1, hypotenuse is m. My opposite will be what? M square minus 1 square root. I'm using Pythagoras theorem here. So to find tangent to x, this is the double angle formula for tangent. We know it is given by 2 tangent x over 1 minus tangent square x. Okay, tangent x I can read from this triangle. You can see tangent is a ratio of opposite over adjacent. Since you divide by 1, so you don't have to write the 1, right? You can write 2 square root m square minus 1 divide by 1 minus square root m square minus 1 square. Okay, can we just square it? This will be 1 minus m square minus 1. Now we square the square root, it disappears. You're left with 2 square root m square minus 1. 1 minus minus 1 is 2 minus m square. Okay? Yep. Okay, second one. You're given a unit circle. P is on the unit circle. You're given x is cos theta, y is sine theta. We're supposed to derive a basic identity involving cos and sine. This is fairly simple because if I see this x, right, move it down, the length from here to here is x. Since it's a unit circle, this is 1. And your y value is y, right? Your y represent the height here. So we know from Pythagoras, if you use, this is part A, this is part B, by using, okay, maybe I write here, using Pythagoras theorem, we know that your x square plus y square is 1 square. 1 square is 1. My x is cos theta. So we write cos theta. Now, normally a cos theta square is written as cos square theta. We don't put the bracket square. We put the square like this. It's just a way of writing. For sine, we write sine square theta. Your outcome is 1. See, it's only 2 lines, right? So using Pythagoras, x squared plus y squared is 1. Straight away sub inside, you get your basic identity. Okay. All right. Next, using this result, we are going to find or solve this trigonometric equation. So from here, we can see that if you want to solve this equation involving cos square and sine, we can only change the one with square. And the one with square is your cos. Cos square, we make it as a subject from the basic identity. Cos square is 1 minus sine square. So I'm going to sub inside here. This is 2 bracket. Your cos square is 1 minus sine square theta. Then you minus 5. The result is 7 sine theta. So let's expand the bracket. This will be 2 minus 2 sine square theta minus 5. Your answer is 7 sine theta. Okay, let me do a bit slower here. This is minus 2 sine square theta minus 3 equals 7 sine theta. Transfer everything to the right-hand side. You get 2 sine square theta plus 7 sine theta plus 3. The result is 0. So what you can do now is to factorize it. And I hope you can factorize very quickly right now without using a calculator. Yes. Take 2 times 3. 2 times 3 is 6. What is the factor of 6? 6 and 1, 3 and 2. And the one that gives us 7 is 6 and 1. Okay, to get 6 and 1, I must put 2 sine theta. This one must be sine theta. One of them has to be 6. 2 times this must give us 6. The other one must give us 1. To get a 6, right, I must put a 3. To get a 1, I must put a 1. Both must be positive. My sine theta is therefore negative 1 over 2 or negative 3. Now remember, your sine cannot be more than 1 or less than negative 1, right? Sine or even cos is always between minus 1 and 1. Yep. Because can you have a sine value where your opposite is anytime longer than your hypotenuse? No, right? Yeah. Opposite can never be longer than hypotenuse. Now, you can get negative, by the way, because negative is 1, 3, or 4 for sine, right? But you can see sine value is my y coordinate based on the unit circle. The smallest unit y coordinate I can ever get is negative 1. Largest y coordinate that I can ever get is 1. So we ignore the negative 3. So take sine theta equals to negative half. Use your calculator. This is in degree, so make sure you change your calculator to degree mode. Let's press shift sine 1 over 2. Drop the negative sign, take the positive value, 30. Your reference angle is 30. Sine is negative. Now you know this again, huh? ASTC, all science teacher crazy? Only science teacher, not math teacher. So sine is positive in quadrant 3 and 4. So we take quadrant 3, 180 plus 30, and quadrant 4, 360 minus 30. Your answer is 210 and 330. There you go. Two answers. Okay, last question from this paper. This is question 15A. So the first part, this is from the chapter logarithm, indices and logarithm. Okay, the first part, you're given log base 12 3 equals to k. You're supposed to find or express log square root 3 8 in terms of k. It looks a bit difficult because you notice that the bases are different. What you're finding, the base is square root 3. What you're given, the base is 12, right? And then the number here is 8. Right, and this is 12, not 4. Yeah, not the same number. Okay, I think I will start off with what I have, right? It's easier to start off with what I have. I'm given log base 12, right? We know we can change the base. Okay, let me write down for you the formula for changing base, log base a b. We can introduce any base, let's say base c here. B stays on top, a stays down. So we write log and log. The original base is 12. We write below the original number 3. We write on top. Starting from here, this is equals to k. The new base, I'm going to use square root 3, square root 3. And I hope you know, square root 3, and if I put a square root 3 here, this is going to be 1. The moment you square it, this is 3, right? Yeah. So therefore, log square root 3 is just 2. This is just 2. Okay, there's a cheat code here. You can use your calculator, log square root 3, but you don't really need to do that, right? Yeah, you don't really need to do this to know that it's 2. Okay, so this is going to be a 2 with a log square root 3, 12 equals to k. I'm going to bring this 12 up. Okay, I'm going to bring the k down. And at this stage, I'm going to break this up because the reason I want to break it up because I need to find the 8, log square root 3 8. Now, we know 12 can be broken down into this. Okay, I'm going to use this calculator again because this calculator is just good function. 12 equals shift factorize 2 power 2 times 3. So we know 2 power 2 times 3 equals 2 over k. Now we can break this up further into log square root 3 2 with the power 2 and log square root 3 equals 2 over k. Now that 2 you can transfer in front. You get 2 log square root 3 2, and we know earlier log square root 3 3 is basically square root 3 squared, so it's actually 2. Right? I hope you know log a power n is just n. Now, some people may say, oh, can I change this to square root 3? The power 2 I bring in front and I say this is 2. Yeah, you can. It's the same thing, okay? So now, this is now 2 over k. So let's divide everything by 2. Well, this is getting very long. You get 1 over k. So my log square root 3 2 is 1 over k minus 1. Now you look at it and say, wow, we're still going nowhere because we are now finding log base square root 3 8. This one. But this is log square root 3 2. Well, not to worry. We know log square root 3 8 is basically log square root 3 to power 3. Power 3, right? So the 3 I can bring in front. So it's just 3 times of what we're getting here, right? Which is 3. 1 over k minus 1. As we multiply inside, you get 3 over k minus 3. Okay? It's a very interesting question. Yeah? AKA difficult, right? All right. I hope you're okay with part A. Now let's move on to part B. So part B, we have a group of scientists in Hawking City discovered an odd organism that reproduced following this equation, that X is the number of resulting cell and T is the reproductive time in hours. So after 10 hours, we are supposed to find a number of resulting cell. That means you're finding X in terms of E. So basically, we have to sub T with 10. So this is ln X over E square. This is now 10 minus 3. That 3, right? I will bring it up X cubed. So for me, I think it's easier if I just transfer this to the left-hand side. So here I got log, by the way, ln means log base E. Ln is log to the base of E. E is exponential. So there is a X over E square here. Then you add ln X cubed. The result is 10. So ln and log is the same. We apply the laws of logarithm when you add a number, we multiply the number. When you add the logarithm, multiply the number inside. So this is now 10. So what we have here is ln X power 4 over E square equals to 10. And you know how to change from logarithm form to index form, right? That is log base A, B, let's say it is C. So B is A power C. Likewise, log base E is ln B, let's say is C, B is, your base is now E, E to the power C. So in this case, we say X power 4 over E power 2. Your base is E, the ln is base E, power 10. Okay, I'm finding for X. So these two I multiply over. X power 4 is E power 10 times E power 2 is E power 12. When you multiply a number, we add the index, the power. So to find X, I need to root this. Root means power 1 over 4. 12 times 1 over 4, you get E power 3. There you go. Okay, your final answer, X is E power 3. So that's the end of the presentation for this video. I hope you learned something in the process or learn a lot in the process. Thank you for watching. I hope to see you in the next video.